Hi, I'm Alex Saroyan, CEO and co-founder of xCloud Networks. At xCloud Networks, we build a software to simplify and automate deployment and management of data center networks based on open technologies. Here's how we see the industry. There's OCP, a great initiative. Hyperscalers show that this is efficient, that it saves total cost up to 30 times. So OCP and open networking is interesting for many large companies, and we can assume that kind of major transformation should happen in the networking. But in many cases, companies are ending up in partial transformation because there are. It's not that easy. It requires some knowledge, especially when we speak not about hyperscalers, but a little bit smaller companies. It requires a lot of knowledge, requires efforts, and sometimes companies are ending up with partial deployment. Here's what we think are the important components for full transformation. So it's made, I just break up into pieces. So there's OCP hardware. There's some other compatible hardware. There's a portion of open source software, things like OpenStack or OpenVPN. It's not hardware, it's just software, but it's a very important part of the whole thing. There's network operating system. There's a great idea of intent-based approach, like I want to define what I need, my final intent, and I want the network to configure everything kind of automatically. And it would be great to have kind of all-in-one approach, like one tool for managing all these things. So our vision is that we connect all these different pieces of puzzle together. That's what we do. And let me show you how we do that. Some stuff from our practice. So we take these OCP switches. We install there our agent on top of operating system. So our agent talks to operating system, talks to BGP routing daemon. It's FRR in our case. We do something similar with regular servers. So we also connect a server to the networking fabric. This is for network functions virtualization or for integration with the things like OpenVPN or integration with OpenStack, this kind of stuff, which is, from our point of view, also a network component. Then we have our proprietary controller and a GUI. So we think that this GUI simplifies life of the network engineer, helps with the deployment and management. Some use cases. So we have a fabric, so we have to connect some servers to the fabric in order to move some packets. So one of the way to do that is routing on the host, which we support a lot. We support some other different things, but we like routing, we like BGP. So with the routing, I think most of you are fairly familiar with the routing on the host concept. Just to make sure we all are on the same page, just very quickly. So we have a host connected with two links to the network fabric. The fabric it's a leaf-spine fabric running BGP unnumbered between switches. Why BGP unnumbered? Because it's just easy to configure. And we're running the same BGP protocol on every link between server and switches. This helps to use both links and be able to do quick switch over, utilize both links. And it's also very useful because when we run BGP on server links, we can use ECMP, the equal cost multipath load balancing feature of the BGP, which is a native thing. So it may sound a little bit complicated, especially for a mid-sized company, but it is configured from this easy-to-use GUI. It's just few parameters. So whatever you need from the network side is basically select these things. So this is the port. This is the physical ports where I connect my server, and this is IP address I wish to configure on my server. That's it. And the configuration will be done automatically. So that's what we mean when we say that we simplify. And what if I want to connect servers like an old school way to layer through domain, VLAN, or whatever you want to call it? We use VXLANs for this thing. So you imagine you're migrating from traditional network to this network, and you want to do as less changes as possible. So you don't want to change all your servers to routing on the host, at least from day one. So you want to go with the old school subnet, mask, and default gateway. So in this case, we do this VXLAN, which is supported by most of the ASICs. So VXLAN encapsulation is done by the hardware. We use EVPN. So we forward VXLAN signaling information through BGP. We do bonding for multi-homed connection of the servers. And again, everything is done with a simple interface. So engineers basically create a circuit, assign IP address, which becomes like default gateway. So this IP address, they assign some ports, or even they can, when they want to, in the future, they want to add more ports, they basically select, put some checkboxes, click add ports to the circuit, click add, and it's kind of bulk action, and it's done automatically. So in many cases, there is no need to understand all the details of commands configured on the switches. However, if engineer still wants to configure something custom, we never block any SSH or the CLI, so engineer can go to CLI and configure any kind of custom stuff. We do ACL, what we call ACL enforcement. So again, useful thing which simplifies life of engineer. So they create kind of ACL, like I want to get access from this IP address to this IP address on this protocol on these ports. And the algorithm running on the switches will figure out the necessary ports by IP address, by MAC address, whatever, and will deploy ACLs on necessary ports using your TCAM in most efficient way. In some scenarios, this helps to solve problem of ACL enforcement within the fabric. If we think about doing this ACL stuff manually, that would be very complex when we think about this on the scale, but doing this through GUI and automated ACLs, it's very, very easy to manage. So ECMP load balancer, I have just mentioned. Again, it is configured through this very easy, just couple of buttons, and technically what it does, so you have, so this is leveraging ECMP capability of the BGP protocol. So you have multiple servers. You assign unicast IP addresses on every server, and you assign the same unicast IP address to all servers. So these switches are installing multiple routes towards the same server, and hashing based on source, destination, IP, protocol, and port. Your internet traffic is getting load balanced towards the servers, your application servers. And beauty of this solution is that it is scalable. The forwarding is done by the switches. So your switching silicon is capable of this kind of ECMP load balancing, because from switch perspective, this is just regular packet forwarding using regular hashing tables. And you can go to this scale. So imagine super spines, and imagine leaf switches on every of these racks. And again, even on this scale, it can be configured this easy, just through a couple of clicks. What if I want to do an application layer load balancer? What if I want to do SSL offloading? And I know that there's different open source solutions like HA Proxy or Nginx, which are very good for doing this kind of stuff, but I would like to really integrate with all my network. So we thought that there's a room to simplify, and we provide, again, graphical user interface for integrating HA Proxy with the switching fabric with running an OCP switches. So you connect a couple of regular servers, install Linux, tell our system that I wish to turn these servers into HA Proxy load balancer. Then we configure ECMP load balancer, which again uses hashing, BGP hashing of the switches to load balance traffic from the internet towards your HA Proxy machines. Then you can terminate your SSL or do some HTTP redirections on HA Proxy machines and send this traffic towards destination application servers. We do, so we also want to connect our data center network to internet. So typically we need an eBGP connection towards our upstreams. So there is a way of doing that, basically adding a new upstream, filling up this very standard IP address, AS number, whatever, getting this beautiful graphs. And that's just in a couple of clicks, and it's configured. Here's how it works. So in case we are using switches in our fabric which don't have enough TCOM to load the full routing table, we do this following, which is good for 20, 30, 40 gigs of traffic, not for terabits, but it's good for up to 40 gigs of traffic. So we connect x86 server to OCP switch with a 40 gig link, and you connect your links to your upstreams to the OCP switch. And when you create your upstream through this dialog, we automatically provision a bridge from that connected port towards server. Our software, which is running both inside the server and inside the OCP switch, will do all the necessary link propagation. So this actually creates router on the stick, but with link propagation, which is like with router on the stick, we have problem with link propagation. Now here we don't have this problem. We listen for, if link goes down, it automatically resets the BGP here, and rerouting is handled properly. With the similar approach, we do native integration with OpenVPN. So like if you have multiple sites, let's say 3 or 5 sites, you want to encrypt traffic between your different sites. So traditional approach could be like installing dedicated firewall in every site. In this way, since we are willing to go open-only technology, so we have OpenVPN, we want to integrate our OCP fabric with OpenVPN to encrypt our traffic between our sites. From GUI, you basically tell, I want to enable site-to-site encryption, and what it does, it configures all the full mesh tunnels between every site. Even if there's 20 sites, it will create full mesh tunnels. We'll configure BGP sessions over every tunnels. So the BGP will calculate the best path and the traffic will go through optimal way. Similarly, if you want to do remote VPN connection, again, using the same OpenVPN, your remote users can connect to one of your sites, or you can do Anycast and your remote users from different countries can connect to nearest sites, then get access to the rest of the hosts. Customer case study. So we recently published this case study with our customer Innova. They are 25 million user base online gaming company. They decided to switch from traditional solution to OCP-based xCloud solution, and they saved like 5 times on operational expenses, and engineer to device ratio was improved 5 times. Like before, they need like 5 engineers for doing things, and now 5 engineers can do 5 times more things. Now they can grow without hiring more engineers, not because they don't want to hire engineers, but because adding more people doesn't really scale. That's the point. So we think that this solution will help companies which are smaller than hyperscale companies to reach to full and what we call accelerated transformation from traditional to open networking. Any questions? Yep.
Hi, just a quick question. In terms of hardware vendors, which ones do you support? You said EdgeCore, other hardware vendors you support today?
No, we support, oops, excuse me. We support most of the OCP hard switches. So that one use case was built with the EdgeCore because customer decided to go with the EdgeCore, but we are operating system and hardware agnostic. So we are trying to support whatever is reasonable and interesting for the target customers.
Hi. So via the GUI, you apply the configuration to all the devices that are required. So it's actually pushing the configuration. But what if someone wants to work for any reason for command line? Does this configuration pull back to the GUI?
Yeah, we don't want to be an evil. So we have this function where you go to the GUI, you tell, hey, Mr. GUI, that's great, that's very easy. But for these 3 ports, I want to put my manual configuration, and then you SSH to your switch and do your custom configuration. So we think that we can automate like maybe 80 to 90% of tasks which are kind of repetitive tasks. But of course, there should be some custom things which network engineers would love to do, and we never want to block this. On the contrary, we want to even help them doing even this manual stuff.
Okay, thanks.
Hi, sorry, another question. So in this previous slide, you showed that there was a controller. These controllers, they are doing just management plane stuff or also control plane stuff? If they do control plane stuff, which protocol they're using to interact with the switches? Thank you.
So this controller is mainly for management kind of stuff. Yeah, it's not like it's not OpenFlow. There's no OpenFlow at all. So there's agents. Our vision is that agent approach is better because you can make decisions from the perspective of the switch, and that helps us to build the distributed system. And we believe that if you want a system to be scalable, it should be distributed. So every switch makes decisions on its own.
Thank you.
Thank you.
Okay, I think we'll stop there. Thank you, Alex.
Thank you very much.